Go through this question. The question says, a bullet of 20 grams is fired from a stationary rifle of mass 3 kilograms. Assume that the bullet moves horizontally. Immediately after the firing, the rifle recoils. It moves back. Okay? With a velocity of 1,4 meters per second, calculate the speed at which the bullet leaves the rifle. Let's start by writing the data here. Okay? So let's write the data in this side. Data. So mass of bullet. I'm going to write bullet with B. That represents bullet. Okay? It's 20 grams. And I cannot work in grams. So I'm going to convert here when I'm writing the data at the same time. That one will be 20 divided by 1,000, which is equal to, yes? 0,02 kilograms. Okay. It's a fire from a stationary rifle. So initially, the bullet was in the rifle. So the initial velocity of the bullet will be equal to the initial velocity. This is initial, eh? Initial velocity of the rifle. I'm going to write R for rifle. Fine like that. The initial velocity is 0 for both of them. Are you with me? Okay. Assume that the bullet moves horizontally. Immediately after, okay, the mass of the rifle, I forgot to write it here. Mass of rifle is 3 kilograms. Okay? Now they say immediately after firing the rifle with a velocity of 1,4 meters per second. The velocity of the recoil of the rifle. So the final velocity of the rifle is equal to 1,4 meters per second. But it's backward. Are you with me? So let's here in the data come and write forward is positive. Are you with me? It means that the final velocity of this rifle at this point is negative because it is backward. Is this understood? And in this first question, they say calculate the speed at which the bullet leaves the rifle. So in other words, it's the final velocity of the bullet. Okay, so for you to get an idea, let's have before and after. Remember I told you this is important. This is before. Okay, what do you have before? You have a rifle. This is a rifle. There is a bullet inside the rifle. Okay? The velocity there is equal to 0. That is what you have initial. The mass are there in the data. What do we have after? We have the rifle. This is after. We have the rifle. I use blue, so let's use the same rifle. This rifle is moving in that direction. Is moving in that direction. Are you with me? And the bullet is moving to the front. It's moving in that direction. And this is what we are looking for. Is that clear? So we're going to use the law or principle of conservation of momentum. So we are coming here. I'm going to start from here. Change in momentum is equal to 0. I said you don't have to start from there. This means that the initial momentum total is equal to the final momentum total. Okay? And to go on there, I have the initial momentum of the bullet plus the initial momentum of the rifle is equal to the final momentum of the bullet plus the final momentum of the rifle. Okay? So I go on and I say the mass of the bullet multiplied by the initial velocity of the bullet plus, this is vectors, mass of the rifle, initial velocity of the rifle is equal to mass of the bullet, final velocity of the bullet, plus mass of the rifle, final velocity of the rifle. you can actually start from here. So you don't have to write everything I did there on top. You can start from there, okay? If you think you're going to forget things, then start from there. It's very simple. You just remember 1, 2, then you change bullet, rifle, boy, skateboard, whatever the objects are involved. So let's substitute everything here. Even though the beginning is a system, let's substitute everything there. So the mass of the bullet is a 0,02. The initial velocity of the bullet before the firing is 0. Plus the rifle is 3 kilograms. The initial velocity is 0. Is when it is inside the rifle. That is before. This is equal to 0,02. The final velocity of the bullet, we are looking for that one. Final velocity of the bullet. Plus, this one is 3 kilograms. The final velocity of the rifle, negative 1,4. There we go. Okay, we are here. Now it's mathematics. You say 210? 210 meters per second. Now, before we finish here, they say calculate the speed. Speed does not have direction. This one is forward. But they want the speed, and the speed don't have direction. So the final answer will be final speed of the bullet is equal to 210 meters per second, and then you stop there. That is the answer. Any question then? Lovely. Now the question continues and says the bullet strike a stationary 5 kilogram block. So the rifle is not part of this system no more. Rifle is out of the work. Now we are having the bullet and the block. Okay? I'm starting again. The bullet strikes a stationary 5 kilogram block. The mass of the block is 5 kilograms. It's showing you there, so you don't have to write it. It's there in the picture. But it's stationary. That is important. Let's write here. This velocity of the block is equal to 0. It's stationary. The initial velocity of the bullet is 210 meters per second. Do you understand? We got it there. Calculated just now. The bullet is brought to rest after traveling a distance of 0,4 meters. So, from the beginning of the block, from here, from this point. Oh, sorry. From that point to this point here. That distance there. This distance there is 0,4 meters. Do you understand that one? Into the block. Refer to the diagram below, and you have the diagram below that. So the initial velocity of this bullet here is 210. That is the velocity with which the bullet is going or is touching the block here. Did you understand? There. Calculate the magnitude of the average force exerted by the block on the bullet. How can we calculate that average force? We can come here and say force, net force. We're going to use Newton's second law in terms of momentum. Is that correct? Right. Newton's second law is say net force is equal to the rate of change of momentum. There we go, divided by change in time. Is that correct? But what could the problem be? We don't have time. We don't have time. Can we calculate time? Yes, we have to go to grade 10 and remember the equation of motion. So how do we calculate time? Let's do it in this side here. Okay. There are many formulas. One simple one, you can go to the examination guideline to get all the formulas. Okay. To me, the simplest one is displacement is equal to initial velocity plus final velocity divided by 2 multiplied by the time. So with this formula, we calculating how long the bullet went into the block up until stopped. Are you with me? Yes. Amazing. So the displacement is given to us. We wrote there is 0,4. So it's 0,4. And you see there? Yes. 0,4 is equal to initial velocity, speaking about the bullet, it is going to be 210. Final velocity, 0. Divided by 2, we're looking for the time. The answer should be, let's write it here, 0,00381 second. That will be the time. Okay, you didn't get that answer. Let's see what formula you get for time. What do you do here, young Tutu? Okay, all right. Now, speed is equal to distance over time. No. This one is only if velocity is constant. All right? Or for average speed. Do you understand? This formula is not correct for this question. It's a wrong formula for this question. Anybody else use another formula? No? So all of you use this one here. I use here like I did. We are very lucky to use the same formula. So everyone use the same thing on me. I'm so proud of you. I'm so proud. Is there any other way to do it? There is other formulas? Yes, let me show you. There is, for instance, final velocity square equal to initial velocity square plus 2 times acceleration multiplied by the displacement. You can use this one to calculate acceleration. There is no time in that formula, is it? There is no time in that formula. You calculate acceleration and then you say final velocity is equal to initial velocity plus acceleration multiplied by time. There we are going back on track. It's double work. But you can do it. You can do it, okay? So we didn't need that one because we use a formula that have everything. Alright, so we're going back now to Newton's second law in terms of momentum. Let's go back to the question. F net is equal to change in momentum over change in time. Now we know the time. And let's substitute everything we have here. F net is equal to change in momentum, mass, bracket, final velocity minus initial velocity divided by time. Okay? There we go. We're working for the bullet. Okay? So, what was the force acting on the bullet? Let's see. F net is equal to mass of the bullet 0,04. Is that correct? 0,04, wasn't it? Okay, sorry, 0,02. You don't have to cry. 0,02. Final velocity of the bullet 0. Stops inside the block. Are you with me? We're speaking now about the time that this in the block is inside 0 minus initial velocity of the bullet. No, 210 meters per second. That was the velocity with which the bullet strikes the block. The time we got was 0,00381. That will give us the net force. How much is that? Negative? How much? 1,100? 1,105. Comma 2. It is a negative number. Are we getting that answer? This is a negative number. What the negative number means? It means if we go back here to the blocks, it means that the force, the block exerted on the bullet was in the opposite direction of the bullet motion. Do you understand? So the force was, in other words, acting on the bullet in that direction. That is the force we are looking for. Do you understand? So the answer was at that number. We're going to check just now. I don't know. Calculate the magnitude. That is why young lady says it's not negative. The answer is negative, but the final answer, the one just the magnitude. So we go to F net equal to 1105,2 Newton. Okay, so please check the calculation, guys. Check the calculation. Let's fix the numbers. Let's fix the numbers here. I get 1102,5 Newton, and then the final answer is positive because I want the magnitude. 1102,5 Newton. Guys, the final question here is saying, let me just, how does the magnitude of the force calculated compare to the magnitude of the force exerted by the bullet on the block? Write only down larger than or smaller to. Guys, how is it? What is the correct answer here? It is the same. How do you know that? Newton's third law. It is the same. The same, and the answer is coming from Newton's third law. I'm going to write Newton third law. That's it.